Okay, welcome to Chapter 2 again, 2.2 to be specific, and this part of the chapter is going to be on tolerances. Okay, we're still talking about limits to measurement, and we need to talk about tolerances and what a tolerance means, but before we can even talk about tolerances, we have to do a little bit of review because tolerances have a lot to do with fractions, and we need to be able to add and subtract fractions. I know this is junior high stuff. You learn it in 10.3 and a little bit in 20-3, but you really have to understand how to add and subtract fractions to do well in understanding tolerances and to do questions that involve tolerances. So the first thing we're going to do on this part of the chapter, and it goes from page 92 up to page 108, so this will be the last video of this chapter, and the last part of this also includes the chapter test. Okay, so there's only 2 videos to this unit. So we're going to talk about adding and subtracting fractions as a review. So if you think you understand how to add and subtract fractions, that's great. You can skip ahead to the next part of the video. If not, you can pay attention here. Okay, so we all know what a fraction is. Okay, now let's get our pen right here. There we go. Okay, now that I've got the pen here, this is a fraction, one number over another number, which means we have a numerator and we have a denominator. Numerator on top, denominator on the bottom. Okay, so let's say we wanted to add 2 fractions together. Let's keep it really simple to start. Let's say we have 1/2 plus 1/2. Well, we all know that half of something added to another half of something is equal to a whole number, because if we have the denominator the same on the bottom, the number on the bottom is the same, we just add the 2 tops, which means that 1/2 plus 1/2 is equal to 2/2. We know that any number divided by itself is equal to 1. All right, so the key here is that when we're adding or subtracting fractions, the only way that we can add or subtract the top number, the numerator, is that if we have the same denominator, the same base. Okay, so let's do something like this. Let's say we have 3/8 plus 4/8. Because the denominator is the same, we can just add the 2 top numbers together. That equals to 7/8. Okay, because the bottom number denominator refers to the same type of unit. Same thing goes when we're subtracting. If I have 7/8, maybe subtract 3/8, because the denominator is the same, I just can subtract the 3 from the 7, and I end up with 4/8. Now we know that this is not a simplified fraction. We want all fractions to be simplified. So 4/8, find a number that goes equally into 4 and 2, or sorry, 4 and 8, which is 4. So if I divide everything by 4 here, top by 4 and the bottom by 4, because 4 goes into 4 1 time and 4 goes into 8 2 times, so we can say that 4/8 is an equivalent fraction of 1/2. Okay, the very, very basics. Okay, so let's go on. Supposing I have something like 3/4 and I want to add that to maybe a number like 3/5. Because the denominators are not the same, I just can't add the 3 and the 3 together to get, let's say, 6 over, well, what number would it be? Would it be the 4 or the 5, or would it be 4 times 5? We don't know. It's not the same. We have to have the same number of units. So what I'm looking for is, when I look at this fraction, I want to find between the 4 and the 5 what we call a common denominator. In other words, what is the lowest number, the smallest number that 4 and 5 will go into equally? Okay, so we have to look at multiples of 4 and multiples of 5, and will a 4 and a 5 go into that number? So I'll start with a 4. Well, we know that if we just multiply the 2 numbers together, 4 times 5, that is going to be a common number. But is there one that's smaller? Okay, 4 times 5 is just 20. But is there a number smaller than 20 that 4 and 5 will go into? So I have to look at multiples of them. So I can pick either one. Okay, so I can take 4 and multiply that by 2 is 8. Okay, 8 is a multiple of 4, but does 5 go into 8? No, it doesn't. So I'll take 4 times 3 is 12. Does 5 go into 12? No, it doesn't. 4 times 4 is 16. 5 does not go into 16, so that's not it. So, and then again, 4 times 5 is 20. Okay, so 20 is the smallest common denominator. So what I want to do is I want to take this, make a line, make another line, and I want to put 20 underneath each one, because 20 is the smallest common denominator between 4 and 5. Now I look at my 4 and I say, well, 4 times what equals 20? Well, it's 4 times 5 equals 20, so I take my number of 3, multiply it by the same number. 3 times 5 is 15. Because 3/4 is the equivalent fraction of 15 over 20. I have not changed my number. I have not changed the ratio. 3 over 4 is still the same as 15 over 20. Now I take my 3/5 fraction. 5 times what number equals 20? Well, it's 5 times 4. So I take my top number above it, 3. I also multiply it by 4. 3 times 4 is 12. Because 3/5 is the equivalent fraction of 12 over 20. I have not changed the number in any way. So now that I have the denominators the same, now I can go back to my same rule that I applied up here. I can add the two top numerators together. So that equals, this number will be over 20. I mean, I don't add 20 plus 20. Same way I didn't add 2 plus 2 to get 4. The denominator stays the same. But I add my two top numbers, 15 and 12. Okay, and 15 and 12 is 27. Okay, so then I look at my answer of 27 over 20, and is that the lowest form that 27 over 20 can be, 27/20ths, or is there a number that goes equally into 27 and 20? They'll divide equally in there. Okay, 2 does not go into here. 2 goes into 20, but it doesn't go into 27. 3 goes into 27, but it doesn't go into 20. 4 doesn't. 5 doesn't. 6 doesn't. 7, 8, 9, 10, nothing. Nothing goes equally into 27 and 20, so therefore my answer is 27/20ths. Okay? This is called an entire fraction, when I just have a numerator and a denominator. Okay, it's called an entire fraction. But if my top numerator is larger than my denominator, I might want to convert it to what I call a mixed fraction. And all a mixed fraction is taking this number 20 and dividing it into 27, and then finding how much I have left over to turn it into a mixed. Okay, so 27/20ths as a mixed fraction, 20 goes into 27 only one time, with how many remaining? So what is the difference between 27 and 20? Well, it's 7, and it's 7/20ths. 1 and 7/20ths. That is a mixed fraction. This is an entire fraction. This is a mixed fraction. And many times you're going to see fractions expressed, or numbers expressed in this form as a mixed fraction, and you have to add or subtract them together. And that's what we're going to do next. So let's do an example, maybe if we're going to add two mixed fractions together. So let's say I have the numbers 2 and 3/4 plus 4 and let's say 3/7. That's an odd number, but let's say we've got these together. Well, what do we do? How do we do this? Well, there's two ways we can do it. We can add the 2 and the 4 together. We can add the whole numbers in front together and then keep that separate. And then we can add the fractions together, 3/4 plus 3/7, get a number for that and then add it together. But there is another way, an easier way. And the fastest way to do it really is to take these mixed fractions and turn them into entire fractions. In other words, turn them into what we know as a regular fraction from this form to that form. And how do we do that? Well, very simple. We take the denominator, which is 4, multiply it by the whole number, which is 2, and then add 3 to it. So 2 3/4 is the same as 4 times 2 is 8, plus 3 is 11, and it's over 4 still. So I could say that this is the same as 11 over 4. 2 3/4 is the same as 11/4, plus 7 times 4 is 28, plus 3 is 31. 31 over 7, 31 sevenths. So when you're going to add two mixed fractions together like this, I think the best way to add them together is to turn them into an entire fraction like this, and then add them together. Okay, now how do we do this? Well, we have to find a common, we do it exactly the same way we did this one here. We find a common denominator between 4 and 7. Well, we can just multiply the two numbers together. 4 times 7, which is 28. That certainly is a common denominator, but is there a number less than that that 4 and 7 will go into? Well, let's look at multiples of 7. 7 times 2 is 14. 4 does not go into 14. 7 times 3 is 21. 4 does not go into 21. So our common denominator is 28. So I take my 4 and I multiply that by what number to get 28? Well, it's 4 times 7 is 28. So I take my top numerator, 11. I also have to multiply that by 7. And that is 77, because 11 over 4 is the exact same number as 77 over 28. It's an equivalent fraction. I have not changed the number at all. And I do the same thing with this number here. 7 times 4 equals 28. So now I have to take 31 times 4. And 31 times 4 is 124 over 28. I have not changed the number at all. 31 over 7 is still the same number as 124 over 28. Because I have the same denominator, all I have to do is add the numerators together, which is 28, and I take 77 plus 124. And 77 plus 124 is 201. So this is my answer, 201 over 28. Now we have to ask ourselves the question, does 28 go into 201, to give me an even number? No, it doesn't. Is there a number that will divide equally into 201 and 28? Well, I don't know, but what we can do is we can take this number of 201 over 28, and because my denominator is smaller than my numerator, or my numerator is larger than my denominator, I can take this entire fraction and I can convert it back to this mixed fraction right here. Okay, and I just take 201 divided by 28. That would be the easiest thing to do. 201 divided by 28 equals, well, it goes into 7 with a little bit of remainder. Okay, that's 7. So 7 times 28 equals 196. And 196 is how many numbers away from 201? Well, it's 5. That basically means that 28 goes into 201 7 times with 5 remainder. There's 5 left over 28, because I don't change my denominator. So if I was going to add these two numbers together, 2 3/4 plus 4 3/7, my answer here is 7 5/28. And that's how we add fractions together. The same principle applies if we're subtracting. The only thing we're doing different, instead of adding numbers together, we would subtract them. Okay, so that is a review of adding and subtracting fractions. All right, so go ahead and work on a few examples in your workbook. The next thing we're going to be talking about is tolerance. Okay, and what does tolerance mean? When we're talking about accuracy and measurement and limits to measurement. Well, all tolerance is, if you look on page 94 of your workbook, all tolerance means it's the measurement variation allowed so that an item is acceptable for its intended purpose. In other words, a tolerance is a measurement that allows an object or a measurement to work for whatever it is it needs to work. For example, if you look on the picture on page 94, we have a wood joint. It's called a mortise and a tenon joint. Basically, what we have is a male end fitting into a female end, a slot or a hole. And what the tolerance is what size does the hole have to be compared to what size does the tenon have to be to accurately and precisely fit in there, and what level of accuracy do we need to have. Okay, the hole has to, and the size of the tenon has to be small enough, okay, or the tenon has to be small enough to fit in the hole, and the hole has to be large enough to accept it. Okay, so what is the range of values, or what is the tolerance, which is basically the range of values, do those measurements have to be acceptable and functioning? Okay, so the tolerance is just determined by subtracting the minimum acceptable value from the maximum acceptable value. Okay, and the target value will be in the middle of those two. So it'll be halfway between the minimum acceptable and the maximum acceptable. And that target is what we call the nominal value. So we have what we call a tolerance. And what we have is how that relates to a nominal value. Okay, so the tolerance is just the variation allowed. Okay, so it's just a variation allowed. Which is acceptable. To function. Okay? And the nominal value as it relates to tolerance is, with a tolerance, you're going to have an upper level, which we call a maximum tolerance. You're going to have a lower level, which is a minimum tolerance. And halfway between there, right in the middle, is our nominal value. Our target is always to aim for the nominal value. Okay, and so from the nominal value, since it's the halfway point, that means our tolerance is going to be plus or minus. Our nominal value will be plus or minus half the tolerance. Okay, or the acceptable value, maximum value, or the acceptable minimum value, our nominal value will be plus or minus half the tolerance. Okay, now you see we've got plus or minus here. That kind of looks similar to maybe our previous lesson of talking about uncertainty. But tolerance, even though we use plus or minus here, is not the same, okay, as uncertainty. If you look on page 95 of your workbook, you'll see on the right-hand margin it says, note that in some forms the way a tolerance is expressed, in other words, because we use plus or minus, it looks like a measurement uncertainty, but tolerance and uncertainty are not the same. And uncertainty shows the margin of error in a measured value. Talked about that last video, while tolerance shows the range of acceptable values for a measurement. So what this tolerance is, it is the range. It is the maximum size something can be, or the minimum size it can be. That's a tolerance, so that the measurement will work. And the nominal value is just halfway between our maximum and minimum tolerance. That's the target value. Basically, we could say that nominal value is our target value. That's kind of what we want to aim for. And all that is plus or minus half, the nominal value is plus or minus half the tolerance. Okay? So if you look on the bottom of page 94, when we're looking at how it can be written down, how a tolerance can be written down, you'll see that it can be written down 4 different ways. A manufacturing tolerance can be written in 4 ways. So take a look at the bottom of page 94 of your workbook. You can see we can write down a maximum value and a minimum value, okay, of whatever our measurement is. It can be written like that. Or we can write it as a nominal value plus or minus half the tolerance. We can look at it from the perspective of just writing down a minimum value with a little side note on there, plus tolerance at the top, subtract or minus 0 on the bottom, because we're looking at the measurement from the perspective of the minimum value. Or we can look at it as from the perspective of the maximum value, which means we have plus 0 on the top. In other words, it's maximum. We can't go any higher, so we can add nothing to it, but a minimum value underneath it of minus the tolerance. Okay, so maximum, it can be looked at it from a minimum value. You can go up to the tolerance, but you can't go any lower, so minus 0. Or from the maximum value, you can't go any higher than the maximum value, so plus 0 on the top. And you can subtract the tolerance on there. So that's how it can be written. And when we're doing questions that involve tolerances, they'll probably be like the 2 bottom ones, from the perspective of a minimum value or from the perspective of a maximum value. Okay, so the best way to understand this is to do an example. So let's go through example 2 on page 95. Okay, and just follow along as I read it, and you can just read it from your workbook. Okay, it says Mackenzie is making caramel candies. The recipe says to use a candy thermometer to monitor the temperature of the sugar mixture. If it is not heated enough, the candies will not hold their shape, and if it's heated too much, the candies will be too firm. So the sugar mixture must be heated between 245 degrees Fahrenheit and 250 degrees Fahrenheit. Part A, what is the temperature tolerance of the sugar mixture? And B, write the acceptable temperature range in each of the 4 ways. Okay, so A, what is the tolerance? So the first thing we need to do is find the tolerance in order to write this tolerance 4 different ways. So all the tolerance is just the difference between the maximum temperature and the minimum temperature allowed to heat the mixture. So it said that in the question, it can be heated to a maximum of 250 degrees Fahrenheit. Let me just put a little separation here. And a minimum of 245 degrees Fahrenheit. So the tolerance is just the difference between the maximum and the minimum. So the tolerance is just 250, subtract 245, which is equal to 5 degrees Fahrenheit. So that is our tolerance of 5 degrees. So let's just write this tolerance of 5 degrees down in the 4 forms that are found on the bottom of page 94 of your workbook. So we can look at it from the perspective of just a maximum value and a minimum value. So we can just write, we'll call this number 1. This is the first way, from the maximum value and a minimum value. And that is 250 degrees Fahrenheit over minimum value of 245 degrees Fahrenheit. This is the first of 4 ways that we could write down the tolerance of this example. Okay, so I'll extend the page here. Now the second way that we could write down the tolerance is to write down the nominal value plus or minus half the tolerance. Well, the first thing we need to do is we need to calculate, okay, well, half the tolerance. All right, so we know that the tolerance is 5 degrees Fahrenheit. So half the tolerance is just 5 divided by 2, which is equal to 2.5 degrees Fahrenheit. Okay, so that's half our tolerance. What we also need to do is we need to find our nominal value. Okay, well, to do this, to calculate the nominal value, we have to add our maximum and our minimum temperatures together and divide it by 2. So we've got 250 degrees Fahrenheit. We have to add that to 245 degrees Fahrenheit. This is how we find the nominal value. The nominal value is just the halfway point. And if we add those two together and divide by 2, we're going to get a temperature of 247.5 degrees Fahrenheit. That is our nominal value, our optimal point that we would want to aim for if we were going to heat up our stove and try to get our temperature thermometer to read the nominal value so that we get the candy mixture not too hard or not too soft. We would want to aim for 247.5, the halfway distance between 250 and 245. Okay, so that is our nominal value. Okay, this 2.5 degrees Fahrenheit, since our tolerance is 5, this 2.5 degrees Fahrenheit is what we call our range. Okay, we have a range of 2.5 degrees Fahrenheit, which is half of our tolerance. It's known as the range. So how do we write this down now in the second form? Well, we look at the bottom of page 94 and we can see that the second way we can write this is the nominal value plus or minus half the tolerance. Okay, so our nominal value is 247.5 degrees Fahrenheit plus or minus our range. Okay, and our range is just half the tolerance, plus or minus 2.5 degrees Fahrenheit. Now notice how if I look at my nominal value and I add 2.5 degrees to it, I'm at 250. If I look at my nominal value of 247.5 degrees and I subtract 2.5 degrees, I'm at 245. I can't go above 250, I can't go below 245. So this is just another way of writing my tolerance, my acceptable range, my acceptable answer or temperature is 247.5 plus or minus 2.5 degrees Fahrenheit. The third way that we could write this down, if we look on the bottom of page 94 again, is we can write it down from the perspective of the minimum value. Okay? Plus the tolerance on the top. Let's spell it correctly here, you guys. From the perspective of plus the tolerance. Now we don't, it's minimum value, so we don't want to go lower than that. Okay? And so how do we write this down from the perspective of the minimum value? Well, we know from the minimum value, the temperature range, this minimum value is 245. We can't go any lower than 245 degrees Fahrenheit. That's our minimum value, so we write down the minimum value. The tolerance, as we stated earlier, was 5 degrees. That's our tolerance. Okay, so I can go 5 degrees higher, plus 5 degrees, but I can't go any lower. So writing it in this form here, I write down my minimum value, plus 5 degrees takes me to 250. I can't go higher than 250, and I can't go lower than 245. And if I look at it from the perspective of the maximum value, I can't go any higher, so I'm going to add plus 0 at the top, and I can subtract the tolerance here on the bottom. So if I was going to write that down, my maximum value is 250 degrees Fahrenheit. I can't go any higher, so I can't add any more temperature to it, so it's plus 0. But I can go lower by 5 degrees, and I can do minus 5 degrees Fahrenheit, because if I was to go 5 degrees lower than 250, I would be at 245. So I can look at it from the perspective of the minimum value or the maximum value. So there's 4 ways that we can write this down. Number 1, we can just write it the way it's shown there, maximum value, minimum value. Number 2, we can look at it perspective of the nominal value, okay, which is 247 plus or minus 2.5 degrees Fahrenheit. Takes me to 250 or 245 on the top or bottom. I can write it down from the perspective of the minimum value, okay, which means I can add 5 degrees to it to take me to 250, but I can't go any lower. Or I can look at it from the perspective of the maximum value, which is 250 degrees. Can't go any higher, but I can go 5 degrees lower. Okay, so that's how you would write down tolerances. You've got one of 4 choices. Okay, so when we're talking about tolerances, that pretty much sums it up. It's just a matter of going through questions in the workbook, reading them very carefully, go through some of the other examples, see how they're solved. It's just a matter of practicing and understanding that what tolerance is, what range means. So you've got to understand tolerance, range, maximum, minimum, okay? Nominal value, really important. Nominal value is just the halfway point between maximum and minimum value, or minimum ranges. Okay. Practice doing fractions, okay, because a lot of the questions that you have to do in your workbook have to do with doing the same thing we have to do here with tolerance, but a lot of the measurements are given as fractions, okay, not as whole numbers, which is something easy like this, but dealing with fractions. Okay, so work yourself to the end of the chapter. Make sure you do the chapter test at the very end. Okay, and that's all there is for chapter 2. I'll put down some more supplemental videos that I'll find on YouTube, and maybe they can help you understand this a bit better. Okay, all right, good luck.